welcome back. So in the last two videos we discussed first question and second question. So now we will discuss the third question, that is, if t1 of n is equals to big O of g of n and t2 of n is equals to big O of g2 of n, then we have to prove that addition of those two, that is t1 of n plus t2 of n, is equals to big O of, so maximum of g1 of n and g2 of n, maximum of g1 of n and g2 of n. So let us prove that. So we have to give the solution. So what they given? Okay, as per the definition, of big O. So big O what says? F of n is equals to, so instead of f of n, so they given in the question t, so you people also take t. If it is 1, t1, so t1 of n is equals to big O of g1 of n if the condition is true. What is the condition? Sorry, t1 of n less than or equals to c1 into g of n. If this condition is true, then this will become true. And take one more, that is for t2. t2 of n is equals to big O of g2 of n if t2 of n is less than or equals to c2 into g2 of n. So now just let us take addition of these two, what it will become. So you have to prove these conditions, then this will become true. So take the conditions. t1 of n plus t2 of n is less than or equals to c1 into g1 of n plus c2 into g2 of n. Okay, so less than or equals to, so just take a constant outside, anything. So c1 one constant, c2 one constant, c1 plus c2, so I can take like this, so multiplied by this one and this one, g1 of n plus g2 of n, simple mathematical, that is multiplied. So just I am taken outside. So now anyhow this is a single constant, so I will take as one small constant, that is c3 g1 of n plus g2 of n. So as we know, right side we will take asymptotic notations. Asymptotic, so if I round off, so we can take, if g1 of n is greater, then you can take g1 of n. If g2 of n is greater, then you can take g2 of n. So I can also write like this, c3 into, so in these two, whatever the maximum, you can consider that either g1 of n comma or g2 of n. So t1 of n plus t2 of n. Yes, this is true. This is true. Hence t1 of n plus t2 of n is equals to big O of maximum either G1 of n or G2 of n. So if you want, you can prove this just by taking small example also. Hence proved. So you can take small example also. Let us consider example by T1 of n is equals to, just take 2n plus 2. Okay. T2 of n is equals to anything, for example 2n square plus n, right? Next, G1 of n is equals to n cube, G2 of n is equals to n square. Whatever you want, you can take. So now just prove this is true for this condition. So just take this condition. You can take equation number 1. So equation number 1 will becomes, so what is the value of T1 and T2? 2n plus 2 plus 2n square plus n. So totally we can write as 2n square plus 3n plus 2. Yes, isn't it? Right. Less than or equals to C3. If you want, you can take anything. C3, for example, constant I will take as 10. Next, maximum of G1 of n or G2 of n. So in this, which one will be the maximum? You can consider that. So what is the maximum here? N cube. I will consider that. Right. So we have to prove this. So just put n is equals to 0. Just check whether that is true or false. 0, 0, 2. That is 2 less than or equals to 0. No, it is false for n is equals to 0. Put n is equals to 1. 2 plus 3 plus 2. That is 2 plus 2, 4. 4 plus 3, 7. 7 less than or equals to 10. Yes, it is true. Next, just take over to one more example. N equals to 2. 2 square, 4. Good. 4 into 2, 8. 8 plus 3 into 2, 6 plus 2, that is 10 plus 2, 16. Less than or equals to 2 cube is 8. 8 tens are 80. Yes, it is true. So 2n square plus 3n plus 2 less than or equals to 10n cube is true for all n greater than or equals to 1. Hence proved. T1 of n plus T2 of n is equals to big O of maximum of either G1 of n or G2 of n. That's it. So that ends this video. Thank you.